Hi everyone, in this video I will going to solve this math exponential equation. The equation we have 2 to the power of k plus 2 to the power of 3k is equals to 10. Here we need to find out the value of k. So let's get started the solution. In the first step, I will going to express this expression in this form. 2 to the power of k plus 2 to the power of k and whole to the power of 3 is equals to 10. Now here we have the common term that is 2 to the power of k. So here I'm going to let m as 2 to the power of k. So in replacement of this 2 to the power of k, I'm going to write m plus m cube is equals to 10, and this I'm going to take to the left hand side. M plus m cube minus 10 is equals to 0. Now I'm going to split this. I'm going to write m plus m cube minus 2 minus 8 is equals to 0. Now I'm going to write this in the form of power. M plus m cube minus 2 minus 2 to the power of 3 is equals to 0. Now I'm going to rearrange the same power together. I'm going to write m cube minus 2 cube plus m minus 2 is equals to 0. Now next I'm going to apply here the algebraic identity, that is a cube minus b cube can be written as a minus b, a square plus ab plus b square. So this is our a and this is our b value. So this expression can be written as m minus 2 m square plus m times 2 plus 2 square plus the remaining part we have m minus 2 is equals to 0. Now I'm going to take here common of m minus 2. M minus 2 I'm going to take common, and here this m square plus 2 times m plus 2 square, and here 1 is remaining, is equals to 0. Now I'm going to simplify it further. So I'm going to write m minus 2 m square plus 2m plus this will be equals to 5 is equals to 0. Now here we have the two cases. M minus 2 is equals to 0. This I'm going to take to the right hand side. So here we get the m value, that is 2. Now our aim is to find out the value of k. So for that I'm going to recall the equation, that is m is equals to 2 to the power of k. So in replacement of this m, I'm going to plug in 2. So here I'm going to write the m value, that is 2, and 2 to the power of k. Here we have 1 power. So here we have the same basis. We can equate the power k is equals to 1. So this is the first value of 1 that we find out. Now I'm going to find out the other value by using the second case. M square plus 2m plus 5 is equals to 0. This is a quadratic equation, and the coefficient a we have, that is 1, and b we have 2, and c we have positive 5. Now I'm going to find out the value of m here by plugging the value of ABCs, and the formula we have minus b plus minus root of b square minus 4ac over 2a. Now I'm going to plug in here the b value, that is 2 plus minus root 2 to the power of 2 minus 4 and 1, and here we have the c value, that is 5 over 2, and the a value we have 1. Now I'm going to simplify it further, so this will turn to m is equals to minus 2 plus minus root of 2 to the power of 2 is equals to 4, and here I'm going to write 4 times 5 over 2. Next, I will going to take here common of 4. M is equals to minus 2 plus minus root 4. I took the common here. 1 is remaining minus 5 is remaining over 2. Now I'm going to simplify it further. M is equals to minus 2 plus minus root here 4 times negative 4 over 2. Now next I will going to apply here the radical rule, that is n root of a times b can be written as n root of a times n root of b. I'm going to write this in separate root. M is equals to minus 2 plus minus root of 4 times root of negative 4 over 2. Now I'm going to separate this negative sign from this 4. So I'm going to write m is equals to minus 2 plus minus root of 4, we have 2, and this I'm going to write 4 times negative 1 over 2. Again, I'm going to write this separately. M is equals to minus 2 plus minus 2 times root of 4 times root of negative 1 over 2. And as we know that root of negative 1 is always equals to iota, the imaginary number. So this will turn to m is equals to minus 2 plus minus 2 times this equals to 2 iota over 2. Now I'm going to multiply this. So this will turn to m is equals to minus 2 plus minus 4 iota over 2. Now this 2 is a common denominator, so I'm going to write with both the numerator. 4 iota over 2. Here this will going to reduce to 1 and this will go to reduce to 2. So here we'll get m value, that is minus 1 plus minus 2 iota. So here we get the two m values, that is m is equals to minus 1 plus 2 iota, and the second one we have minus 1 minus 2 iota. Now I'm going to plug in this value in the equation that we let. M is equals to 2 to the power of k, and now I'm going to plug in here 2 to the power of k is equals to the m value minus 1 plus 2 iota. Now I'm going to take log both the side. Log of 2 to the power of k is equals to log minus 1 plus 2 iota. Now here I'm going to apply the logarithm rule, that is log of a to the power of b can be written as b log of a. K log of 2 is equals to log of minus 1 plus 2 iota. Now here this log of 2 is multiplying, so it will going to be divide both the side. Here this and this get cancelled. Now this can be written as k is equals to log base 2 minus 1 plus 2 iota. So here we get the second k2 value, that is the imaginary solution. I'm going to plug in the negative value of m in this equation. M is equals to 2 to the power of k, and 2 to the power of k is equals to minus 1 minus 2 iota. Same as here, I'm going to take log of 2 to the power of k is equals to log times minus 1 minus 2 iota. Now this I will going to take in front. Log of 2 is equals to log minus 1 minus 2 iota. Now this log of 2 is multiplying, so we're going to be divide both the side. This and this going to be reduced, and here we'll get k is equals to log, I'm going to write as base, and this negative 1 minus 2 iota. So here we get the third K3 value. So this is the final answer. Thank you so very much for watching my video. If you like my video, please do hit the like button and please support my channel by subscribing it.